Hi, we're Shil and Rahul, and our project is CS PUN94. Now, as you can tell from the title, our project is given a topic or a word we want to generate a pun. So what makes a pun? Here's a dictionary definition, and by it we see that swapping definition or swapping sound generates a pun. Next, we have an example. Kevin wrote a song about tortillas, so this sentence creates the context for the pun. Actually, it's more of a rap. So here's where we get the surprise that actually makes a pun a pun. We expect the word RAP, but we replace it with the similarly sounding WRAP to generate the pun. One of the biggest problems that we faced was that we couldn't use classical models for three main reasons. There was no standardized structure because no two puns are the same. It's hard to evaluate pun quality because humor is very relative. And lastly, we had a scarcity of labeled data because it's even hard for humans to generate puns. So our wonderful solution was to copy humans, both literally and figuratively. We got inspiration from the paper Pun Generation with Surprise and focused on three main points. We wanted to establish a primary context, find a homophone, and sprinkle in secondary context. So I'll pass it on to Rahul to go ahead and give you an example of how we did this.
Yes, let's see this sort of approach in action. And in particular, we're going to show you how our model runs. And so first off, quick 180, we're just going to open up our website. We're going to start by entering our query here into there. And as it's generating on the website, we can talk through what's exactly happening. So the first thing that's happened is that we need to establish that context. And so our model will scrape from a website to find sentences that contain the query word hair. In particular, we want sentences that have the word hair near the very end and are relatively short. This is because it leads to A, greater surprise, and B, a more snappy, punchy sentiment. The second thing that we want to do is we want to find homophones for that word hair. In particular, what we do is we start by scraping for rhymes. After that, what we do is we look at the pronunciation hashes of the rhymes that we've been provided, and we try to use the minimum Levenshtein distance to find the rhymes that are most similar sounding to the given query word. These are more likely to be homophones, and then we just do a quick part of speech check to ensure that they're the right kind, as well as a first letter check to ensure that the sound is the same. After that, we take our sentence, an arbitrary sentence, and we swap in the homophone. So in this case, hair becomes hair, as in like royal lineage. From there, what we want to do is we want to find context. We want to add in that secondary context using that word heir. So given that it's dealing with royal lineage, the top three words that we see are son, brother, and uncle. And this is based on just a word embedding model like glove. From there, now we need to find a sentence, a word in the sentence that we have to swap in our sort of secondary context. In particular, we want nouns. So we look at part of speech, and we notice the word mother tends to be the same part of speech as son, and we swap it in. We also do a pluralization check. So if it was mothers instead of mother, we would make it sons instead of son. We swap it in, and now our pun is done. The thing is, though, is that just one pun. And we had 5 sentences, 3 homophones, and each of them having their own various assorted contexts, and leading to maybe 70 odd, 80 odd sentences. And so now all we have to do is we have to rank these sentences based on pun quality and surface the 3 or 4 best ones on the website for the user's consumption. And the way that we do this is that we look at the popularity of the words in that sentence, so the sum of the popularities of the individual words. Normally, we would use a rank for funniness, but because there is no such metric for funniness, we felt that popularity is a good proxy because it means that it's going to be digestible to a wide audience. We also look to ensure that there's no grammatical errors. A very common one that we ended up seeing in our model was double nouns, and we filter that out using basic grammatical checks. And that's it. Those are our puns. And as you can see on the website, those are the same puns that appeared right over there. Now I'll pass over to Shield to show some other puns that we generated in addition to the one for just this query word here.
So next we have a few examples. On the left, we have examples that generally did well, and on the right, we have some that didn't do as well. So on the top left, we actually have our personal favorite. We were all a bit binary after staying up all bite to finish the report. So bite replaced night in this case, and it actually had the word bit already in it. So it made the pun all the better. Next, we have Anon sacrifices dog on move 22, getting a rook and bite in return. So it's a chess pun, and it works really well because it sounds like the dog bit Anon for sacrificing the dog. And we have 2 other good examples that follow the structure and do everything as we described to create a great pun. However, we also did have a few bad examples that came out, which are on the right side. And the general trend that we saw was that the sentences were sometimes a little bit too complicated, in which case the puns generated were not good. The homophones that we found were not good home words to just use in general to create puns or to get similar context with, which created sentences that didn't create good puns. And lastly, we had some that just sounded like regular sentences because we couldn't create a good humor metric for those examples.